Imagine a summer night where your city is a full 22 degrees Fahrenheit warmer than the nearby countryside. This isn't just an inconvenience, it's a silent, persistent climatic reengineering with profound consequences. We will explore how centuries of design decisions created this invisible blanket, and why its heaviest burden falls on the most vulnerable among us. This phenomenon is known as the urban heat island effect. Cities and metropolitan areas are demonstrably warmer than their surrounding rural regions. It's a direct result of human development and sustained activities. Across the United States, daytime urban temperatures average 1 to 6 degrees Fahrenheit higher. When night falls, the difference often grows, with urban areas experiencing 2 to 5 degrees Fahrenheit warmer conditions than rural areas. And in highly developed city centers, mid-afternoon temperatures can soar, often 15 to 20 degrees Fahrenheit higher than surrounding vegetated zones. These aren't minor fluctuations. Why this stark difference? Look down. The pervasive dark surfaces of our cities, asphalt roads, concrete sidewalks, dark roofing materials, have a critically low albedo. This means they absorb a massive amount of solar energy. They convert it into heat rather than reflecting it back into space. Albedo, in fact, holds the largest influence in calculating urban heat island values, but absorption is only part of the story. Urban materials like pavement, concrete, steel, and brick possess a much higher heat capacity than natural surfaces. They store vast amounts of absorbed solar energy during the day. As the sun sets, they slowly release this stored heat into the night air. Consider concrete. It can hold approximately 2,000 times as much heat as an equivalent volume of air. This constant storage and release is amplified by what's missing: the replacement of natural landscapes and vegetation with these impervious urban surfaces eliminates critical natural cooling mechanisms. We remove shade. We prevent evapotranspiration. These are powerful, innate processes designed to regulate temperature. This reduction fundamentally alters the local thermal balance. Evapotranspiration is the process where liquid water from plants and soil transforms into vapor, releasing it into the air. This transformation absorbs heat energy. It actively cools the surrounding environment. Without it, our cities lose a vital natural air conditioner. Restoring this process, alone or with shade, can reduce peak summer temperatures by 2 to 9 degrees Fahrenheit. It's not just about what covers the ground, it's also about what stands above it. Tall buildings and narrow streets sculpt what we call urban canyons. These canyons restrict wind flow, impeding the release of trapped heat. They capture radiant energy, leading to even higher air temperatures. The city's invisible blanket is not just formed, it is actively trapped and intensified by its very architecture. How does this system perpetuate itself, day and night, making our built environment an active participant in its own overheating? Beyond absorbed sunlight, we generate heat ourselves. Vehicles, air conditioning units, our buildings, and industrial facilities all pump out significant amounts of heat. This is known as anthropogenic heat. During a summer heat wave, the air conditioning from urban buildings alone can add 20% more heat to the outside air. It's a self-reinforcing cycle. Specific weather conditions intensify this effect. Calm and clear skies maximize solar energy absorption and minimize heat dispersal. Strong winds and cloud cover, conversely, can suppress these heat islands. The largest urban-rural temperature difference, the maximum heat island effect, is most frequently observed 3 to 5 hours after sunset. This is when all that stored daytime heat finally radiates outwards. Adding to this atmospheric trap, urban environments often contain higher concentrations of pollutants. These pollutants can act like a miniature greenhouse layer suspended above the city. They prevent outgoing thermal radiation from escaping into the upper atmosphere. This effectively thickens the invisible blanket, making it even harder for the city to cool down. This thermal burden is not shared equally. Historically disadvantaged communities, particularly communities of color and low-income populations, experience significantly higher temperatures within cities. They are often surrounded by more heat-absorbing infrastructure, with fewer mitigating green spaces. This is a stark illustration of how urban design choices ripple through society, creating unequal environmental burdens. The city's invisible blanket is not merely an incidental effect. It is a thermodynamic echo of human design. It is a persistent, self-sustaining thermal system reflecting centuries of urban planning, material science, and energy consumption choices. We have inadvertently re-engineered local climates, prioritizing immediate function and density over bioclimatic harmony. This re-engineering has created unintended climatic consequences. These consequences disproportionately impact vulnerable communities. They escalate the challenge of urban resilience in an era of global warming. Every decision, from the color of a roof to the presence of a park, contributes to this echo. It shapes the daily lives and long-term health of millions. The city's invisible blanket isn't an accident. It's a deliberate, if often unconscious, inscription of our priorities onto the very air we breathe. Understanding this echo is the first step towards retuning our urban future. We must acknowledge this deep-seated relationship between our built environment and our climate. The choices we make now will define the climate of cities for generations to come.